Okay, so we're going to look at summation notation, and this may or may not be on your final exam, I'm not real sure, but you'll definitely see summation notation in calculus, and you can also use summation notation when you're working with sequences that we're going to look at in the next couple of lessons, so arithmetic and geometric sequences. So we're going to look at just basic summation notation, and so before we look at summation notation, we're going to look at a reason why you would want to even have this. So sometimes it's useful to find the sum of the first so many terms of a sequence. So we're going to look at a real life example, and I completely made this up. This is really not the number of outbreaks of tuberculosis in North Carolina. But the number of outbreaks of tuberculosis in North Carolina are given in the table from 2001 to 2008. So here are all of our cases of tuberculosis. And so to find the total number of cases from 2001 to 2008, I would say I'm going to let this be A1, A2, A3, A4, 5, 6, 7, 8. And so we would add up all of those terms, A1 through A8. And if I did that, 5 plus 6 plus 8 plus 11, 12, 12, 10, 11, if I added all of those up, that would be 75. So a lot of times it's useful to write what you're doing like in a shorter notation rather than say A1 plus A2 plus A3 plus A4, blah, blah, blah. So this is where summation notation is useful. So we can express the sum using summation. So like we said, A1 through A8 will be expressed by this sum right here. So what this means, this little E, first of all, it's like E, is just the Greek letter sigma, and it just represents a sum. Now, this number right down here is your starting point. This number right up here is where you stop. And so what this sum means, you would pronounce this, okay, in the quotations, the sum as I goes from 1 to 8 of A sub I. And so what that means is if we plugged in 1 for starting at 1, if we plug that in, I would have A1. And then I would say plus, because this is a sum. And then I'm going from 1 to 8, so I would say plus A2 plus A3 all the way up to A8 like I've got written over here. And so that's just all this sum means. And I'll call these, when I think about these, in high school I used to think of them as they looked like a hand, like an old lady hand with somebody that like had arthritis. So I call these old lady claws. And so if you hear me say that, that's just why, because I call them the old lady claws. So anyhow, let's just expand and evaluate this sum. And so I'm going to write them out, or some of them out until you get the hang of it. So I'm going to go ahead and write this one out. This is just me taking the first term, which is 1. So I'm going to say 1 squared plus 1 plus 2 squared plus 1 plus 3 squared plus 1 plus 4 squared plus 1 plus 5 squared plus 1 plus 6 squared plus 1, and then I'm going to stop because 6 is my stopping point, and then I'm just going to add all these up, and you can type them in the calculator, or you can try to do them in your head. I'm going to do, these are pretty easy to do in my head. I'm going to say 1 squared is 1, plus 1 is 2, plus this would be 5, 9 plus 1 is 10, 16 plus 1 is 17, 25 plus 1 would be 26, 36 plus 1 would be 37. And so then if I add all of those up, you can just type those in the calculator, I would get the sum is 97. And so that's really all you're doing. Alright, let's do another one. So this one, my starting point is not at 1, my starting point is at 4. And so I'm going to plug these in. I would say negative 2 to the 4th power minus 5 plus negative 2 to the 5th power minus 5 plus negative 2 to the 6th power minus 5 plus, and then negative 2 to the 7th power minus 5, and then that's it, because I went from I equaling 4 to 7, and so I would just have these 4 terms. And so you could individually plug these into the calculator if you wanted to. Negative 2 to the 4th would be 16, minus 5 would give me 11. I just like to plug it in my head. Negative 2 to the 5th would be negative 32, minus 5 would give me a negative 37. plus 2 to the 6th would be 64, minus 5 would be 59, plus, and then negative 2 to the 7th would be negative 128, minus 5 would be negative 133. And if you add all of those up, that's going to give me negative 100. And so my sum would be, this sum would equal negative 100. And again, you can plug all that in the calculator. Now this one is a little bit different because there's nothing that there's nowhere I can plug anything into. So all of this means is I have 1 through 5 terms. So I'm going to say 3 is my first term, plus 3 is my second term, 3 is my third term, 3 is my fourth term, 3 is my fifth term. And so basically this just means I'm adding 3 up 5 times. So this is 1, 2, 3, 4, 5. And so I stopped at 5 because my stopping point was 5. And so then when I add all those up, that's just going to be 15. And so if you just have a number, you're just going to write it out the number of times that from your start to your stop. Now let's go backwards. So I want to take a sequence or a sum, and I want to be able to write it in summation notation. So first I'm going to draw the old lady claw. And so I can tell whenever I'm looking at these summations or this sequence or series here, I'm just going to look and see what number is changing. So this 3 is always the same. And so the number that is changing is the 1, 2, 3, all the way up to 7, that base. And so whatever number is changing is what's going to be I. So I'm going to say I to the 3rd, and I is going to start with 1, and then I is going to end at 7. And so then this would just be my summation for that series right there. Alright, last one. Now, this one is really not too bad because they're giving me my pattern here, okay? I'm going to draw my little old lady claw. The thing that never changes is the 1 in the top. And even this first term is like a 1 over 1. So that the 1 in the top is never changing. So I'm going to leave that there. And then it tells me that right here, the pattern that's going on in the bottom of the fraction is 3 to the n minus 1. So n is just like I, whatever number I'm going to plug in there. And so the way that I would write this is I can look and see that my first denominator is at 1. So I is going to start at 1. And then I'm going to go up to, this sum ends at n, at some number. And so it's going to end at n, and then I would just say 3i minus 1 is in my denominator. And so let's check this to make sure that it's correct. So if I plug 1 in for I, 1 minus 1 would be 0, and 3 to the 0 would be 1, which is what I've got in the bottom here. If I go up to 2, 2 minus 1 would be 1, and 3 to the 1 is 3. If I go up to 3, 3 minus 1 would be 2, and 3 squared is 9. If I go up to 4, 4 minus 1 is 3, and 3 cubed is 27. And then this last term, I need to be able to get this, 1 over 3 to the n minus 1. If I plug in for I, then this is exactly what I get. And so this is how I would write that summation. And so I'll have a worksheet for you on how to practice going back and forth between the two different methods, finding the sum and then writing the sum.